about these rules are that the derivative of a constant is equal to 0. Now that's different than the limit as x approaches a of a constant equals that constant. So when we learn the limit rules, keep in mind that we have limit rules and rules for dealing with the limit symbol, and then we have separate rules which deal with taking derivatives. So you want to keep those two separate in your mind. Some of the rules are okay to overlap, and number 4 is one where it's okay to overlap these ideas. And rule number 4 says that the derivative of, that's what the d over dx says, derivative of f of x plus or minus g of x is equal to the derivative of f of x plus or minus the derivative of g of x. All right, so in words, what this is saying is that if you have two functions and they're either added or subtracted together, and you want to take the derivative of the entire expression, well, you can take the derivative of each part separately. So functions that are combined through addition and subtraction, you can take the derivative of each part separately. So here's an example. See, the derivative of x to the 6th minus x squared. Well, our derivative rule says that we can distribute the d over dx. So we have the derivative of x to the 6th minus the derivative of x squared. And so now I know how to take the derivative of x to the 6th. I use that power rule, which said bring the 6 down in front, and x is now raised to 1 less. So I have 6x to the 5th minus our derivative of x squared. I bring that 2 down in front, and my new power is a 1. Now, x to the 1st is the same as just plain x, so I really don't need to write that 1 in there. I can just write this as 2x. All right, are there any questions about that derivative right there? Okay. All right, rule number 5 says that the derivative of a constant times a function f of x is equal to c times the derivative of f of x. Now, that's a little bit obnoxious, right? Because we know that the derivative of a constant, when that constant sits by itself, if there's no function, so if c is just sitting by itself, its derivative is 0. But if c is multiplied times some function, then we're going to bring that constant out in front and take the derivative of the function that we have. So here's an example. If I have h of x is equal to 3x squared, then what I have here is a constant, which is my 3, times my function, which is f of x, that's my x squared. And so h prime of x will be 3 times the derivative of the x squared. Okay? So h prime of x will be, carry along the 3, take the derivative of the x squared. The derivative of x squared is 2x. Bring that 2 down in front, x to the 1st.
But they stay separate.
And you can leave them separately, but after about the first 5 of them that you've done, you're automatically going to multiply those 2 together and get 6x. Okay. So now that we have 2 more rules, I'd like to look at another example that combines all these rules together. For example, if we have f of x is equal to 15x cubed minus 2 over x to the 4th plus 6 times the square root of x. All right, so first thing I'd like you to do is to take a moment and thank your lucky stars that we don't have to calculate the derivative of this using the limit definition of a derivative.
Yeah.
All right, so now let's take this derivative. In order to calculate f prime, I have some things going on here that I don't know what to do with just yet. For example, 2 over x to the 4th. I don't have a rule that deals with division. So I've got to rewrite my power so it's 2 times x raised to a power. So the first term is fine. I still have my original function. That's 15x cubed minus 2x to the negative 4. And then that square root, I want to rewrite that as a power as well. And so we have plus 6x to the 1/2. So when I see some sort of a long function like this one up here, I first want to analyze it and say, okay, what I see is I see 3 separate functions that are combined using addition and or subtraction. And for each of those functions, I want to rewrite those functions so that I have x raised to a power. So when I have a division sign, that means raising to a negative power. When I have a root sign, that means raising to a fraction. Once I've done that, now I can look at this function and take its derivative. So now I'm taking my derivative, so I've got f prime rather than f. For my first one, I have a constant times x to the 3rd. So 15 times x to the 3rd, I'm going to carry along the 15 and take the derivative of the 3x squared, of the x cubed, which is 3x squared. Minus, I've got a 2 times x to the negative 4th, so I carry along the 2, take the derivative of the x to the negative 4th. So that derivative will be negative 4, and I'm going to subtract 1 from negative 4, which gives me negative 5. So I've got negative 4 times x to the negative 5. And now I've got a plus sign, and I'm going to take the derivative of the 6x to the 1/2. So I'll carry along the 6. Take the derivative of x to the 1/2, means bring the half down. And I now have x raised to the negative 1/2. Now the negative 1/2 comes from the old power minus 1, so that's 1/2 minus 2 over 2, which is negative 1/2. All right, now I did say that I don't want to simplify, but I do like to multiply these numbers together. So 15 times 3 is 45x squared. And then we have plus 8x to the negative 5 plus 3x to the negative 1. And this is our derivative.
So how would do that with like a sine or cosine function?
We're going to see that. Hold that thought.
Okay.
Instead of f dash of x,
F prime of x?
f prime of x, you can write d over dx and put the function inside there.
That's correct, yes. Okay, other questions about this? But you're right, we don't have any trig rules yet. These are strictly power, we have the power rule, and we can throw constants in front, and we can add and subtract things involving power, and that's all we have so far. All right. That was number 5. Number 6.